The final step on our gyroscope frame construction will be drilling holes and tapping the two ends of the frame here. So when it sits this way, and that allows us to insert a couple of brass pieces that will turn down here, some threaded pieces that will turn on the lathe, and those will act as bearing supports for our spindle and rotor. We're going to use our edge finder to find the edge of our part, and then knowing the thickness of a part, we will move over half of that thickness and center ourselves in the Y direction. Once we've done that, we'll come over and touch off on either sides of the part, symmetrical part here, and that'll allow us to center over the X straight over this flat spot there. Then we'll go ahead and call that our origin of 0, 0. We'll do a little center drill, which is similar to when we use the punch to start the drill bit. Then we'll come drill it, and then we'll tap it. All right, so I'm going to bring my edge finder down. Okay, I'll lock the quill off there. All right, I'm going to go ahead and move in the Y direction. Let's actually slow this down just a little bit. Okay. See that wobble a little bit better on camera, maybe. All right, so we're going to bring this in. It's looking smoother, smoother, smoother. And it just kicks over there. You'll probably be able to see this in better from the other angle of the camera. So this is my Y, zeroing that out, enter. All right. Now I'm going to go ahead and raise my quill. Shut this off for a second. Okay, so we take a measurement of our part itself. We know this should be right about a quarter of an inch or so there. Let's see if you can see that on there. So on our scale here, we've got 0, 0.1, 0.2, and we're not quite to 0.3, so we're at 0.2 plus whatever's on the dial here. So 0.255, well, 2.256 or so. So we want to take half of that, so about 0.128 would be the center of our part. But we also need to account for the thickness of our edge finder here. It had a radius of 0.1, so we need to add that 0.1 to our zeroed Y value here in order to move over to exactly the middle of that. So 0.1 plus 0.128 is 0.228. So I don't know if you can see the display up there. Hopefully you can. We're going up to 0.2, 2, 4, 5, 6, 7. Right there, 0.228. Now we're centered right over that part. I want to walk around here and just kind of confirm. Never hurts to do a good visual check on that. So now I'm going to lock off the table in the Y direction. And I'm going to go ahead and move just some arbitrary distance here, and then bring our quill down, and this will allow me to touch off here for the X direction. So I'm on the side of the part there. Got a little bit of wobble in there. I'm going to give myself a little bit more clearance here. Okay, I'll lock that quill off. Start up. So hopefully from this camera here you can see the wobble. It's going to clear up and it'll kick off to the side here. And it might be a little bit easier to see from that camera. So okay, we don't need to move our Y. We're going to go ahead and zero our Y out. We'll get that on 0. Just until it goes smooth and then kicks off to the side, right about now. Okay, so I'm going to go ahead and zero the X on this side. And then we don't want to change our Y because we need to make sure we stay symmetrical. So I'm going to go ahead and unlock my table here. We'll just move the Y out of the way. We've zeroed that so we know where we're at. We'll come over to some distance here, make sure I'll clear on the other side. We're going to bring our table back and the Y to 0. Close to that anyway, it's not real important for this maneuver. And then sometimes you need to tap your edge finder to get a little extra wobble in there. Don't use your fingers. Oh, let's try that again. I came in a little fast on that one. We're going to come in, just touch until it goes smooth, and you'll watch it kick to the side right there. All right. So now I can go ahead and actually shut the machine off. Stop squealing, move that up. So I've measured the exact distance from one side to the other, 1.0932. So I'm going to take half of that. No, I don't bother to do any of the mental math here. We all have a calculator in our pocket, so 1.0932 divided by 2.5466 will get us back over the center. So I'm going to go ahead and just move that over. 0.54. Oops, missed it. 5468. That's good enough. All right, so I'm going to lock my table in the X. My table's locked in the Y. I'm going to go ahead and zero my X out. So now we have a 0, 0. And you may be asking why when I did the X, I didn't need to account for the thickness of my edge finder. That's because I measured on either side of the part, either side of it, so the thickness basically canceled itself out. When we measured from the front or back edge and then took the thickness of the part, we needed to then account for the thickness of our edge finder and move over that 0.1. All right, so next thing we're going to do is swap out our edge finder for a drill chuck. We'll do a little center drill peck on there, and then we'll drill that out. Okay? So let's go ahead and grab our, raise the quill. Okay, we'll tap to get that out. Okay. All right, so this is a center drill. You can see in this camera here, it's basically a really short, stubby, just the tip of a drill bit basically, and it's really rigid. And as I mentioned, just like starting with a punch or something, this gives a little dimple to get the hole started. Then when we come through with our drill bit, which tends to have a lot more flex and wobble to it, that'll give us a nice straight guide for that. Right. And just going to touch off on that. All right. That's it for that one. I don't know if I mentioned this before, but just like the wrench on the top, and as I'll mention with the chuck key on the lathe, don't take your hands off of that. Don't ever leave that in the chuck. When it starts up, it'll go flying like a Russian shop roulette. All right. Now we can speed that up a bit. Break those chips off as we go. All right. Okay, and while we have everything nice and lined up here, take out that drill bit there. All right, we're going to quickly switch over and do our tap. Okay, so this is a little tapping aid. It's spring-loaded in there, and that'll allow us to sorry, that'll allow us to lock in with the little hole that's on the back of these tap wrenches, T-handle on there. So we can lower that in like this. And then I'm going to bring the quill down, so hopefully you can see that. bring the quill down, and I'm going to put a little bit of pressure on this guy, stop about there. And then with some downward force, gently, we're going to rotate around. And actually, this is a good time to talk about lubrication. So tapping is one time when you always want to use some sort of lubrication on there as we're cutting into it. General, prototyping one-off type projects in a lab like this, when you're cutting aluminum, lubrication is generally not needed, and it helps us reduce the amount of hazardous materials that we handle and have to dispose of. Later, when we're cutting steel, we will use some cutting fluids on that, some oil for that. On steel, you do want to use it, you need that lubrication and that cooling for it. The lubrication is also really important when you're doing a tap. There's a lot of force involved here. This is sort of a forming thing, so you're really kind of applying a lot of pressure in there. So you need a little bit of oil in there to help those slide by. If you don't, you're likely to sort of gum everything up. You'll literally strip the threads out that you just made. Everything will kind of bind up in there. So just a drop or two of, this is specifically made for it, rapid tap, cutting fluid, heavy duty oil. All right, so we're gonna go ahead and go forward with this. You get the first couple of turns, make sure the threads are started. You'll start to feel a little bit of resistance. You wanna back up about a half turn or so. That breaks off the chips that have been forming as you're cutting the thread. It goes down. Again, start feeling a little bit of resistance, back that up a little bit, go, back it up. So it's this process of working forward and backward. Like this. We'll just work on it. I'm just keeping a gentle amount of pressure. The spring-loaded piece in there kind of keeps the pressure on there for us. Nice and gentle. You can do this, put the part in a vise and do this by hand, but it's a lot easier to get your threads a little crooked in there. All right, so we're all the way through. And we'll just back up here. Okay, at this point, I can raise my quill out of the way. And we have one more to do after this. All right. Very good. All right, now we can just flip our part over in the vise here. Let's make sure we don't have any chips that have fallen down in there. This is why you don't wear loose jewelry, loose clothing when you're working in a machine shop. Oh, I don't like have to do this. All right. Okay, so we've already found 0, 0, and our part is symmetrical. We've got it locked in a soft jaw on the vise here that basically locates the part for us. So all I've got to do now is swap this guy out. Drill chuck back in there. Center drill in there. That's it. And a drill. now we'll put our little, I call it tapping aid in there. So, where did I set my tap? There we go. Okay, bring that down. And we'll put a little drop of oil on it. I need to set this to some music or something. And tap it, we will go. Okay, and we'll just check now and see if our threaded piece will fit in there. Yep, perfect. All right. So now we will move on to the lathe.